Hi folks, this is Dr. Robertson, and I wanted to give an example of a factorial design experiment. This is one that I did, but I thought it might help illustrate some of the features that you get with a factorial design. And so this is one particular application, and this may help you understand the readings, but also understand the questions involved in Lab 9. So a factorial design is one where you have two or more independent variables. Now, the example that I'm going to give you is one from language psychology, because that's the kind of work I do. And this study in particular was looking at negation. Now, negation is, as illustrated here, a negated statement in English, one way to do that is simply to add a negation marker, such as not. So we could say it is raining, or we could say it is not raining. The idea, at least in theory, for the dominant theory at the time when I did the experiment, the theory of how people understand negated sentences is that first they understand the original sentence, it is raining, and then they form a representation in their mind of what it is raining would mean, and then they say not that. So this was using, in terms of the theory, it had the idea that when we understand a sentence, what we do is form a propositional representation. So this is applying ideas from logic and computer science. And so first you get the it is raining, and then you say not whatever that is. Now, in understanding, so thinking of language a different way, one of the things that stands out is when I say it is raining, you know what the weather's like. It's raining. When I say, like for today, it is not raining, you know what the weather isn't, but you don't know what it is. Is it sunny? Is it cloudy? Is it snowing? Is it, there's a lot of things that are not rain that are consistent with it is not raining, but not, you don't know which of those situations is correct or not. And so from that point of view, a negated statement is inherently ambiguous, that they tend to be less clear, less concrete, and more ambiguous than a similar statement without the negation marker. Now, for the experiment that I'm going to tell you about, we did a factorial design where we have sentences like it is raining, and we have that in positive form, and then we have the negated form where we've just add it isn't raining. So just add the nt, is how we laid out the stimuli. Now, we also manipulated the context. So when people were reading these sentences, they were embedded in a paragraph. And the paragraph that preceded it either conveyed information that would disambiguate, so make more clear what the negation was about, or they didn't really help you with that. So an example for that is Dr. Robertson has a really weird home office. There is a whiteboard. Or Dr. Robertson has a really weird home office. There is no whiteboard. Now, by saying really weird home office, then you might expect, so that conveys to the reader to expect something that is out of the ordinary. Now, having a whiteboard in your home office, even a weird one like mine, it is something that you would expect. And so by saying weird home office, finding out that there is no whiteboard that would be consistent with that. And so we set up a whole bunch of sentences like this that were either positive or negative, and were preceded by a paragraph that either supported the negation or didn't support the negation. So we have two independent variables. We have negation, positive or negative, and we have the contextual support. So did it support or did it not support? And on my graph, and I apologize because I have to write mirror image here. Did I do it right? It looks supported, and 0 is going to be not supported. I can't get this camera to go right side out. So everything's, oh, that doesn't look great, but hopefully you can make sense of it. Now what we did was measure the reading time. We also had comprehension questions to make sure they're paying attention to it. Performance on the comprehension questions was really high, and there weren't any statistical differences that were able to be seen. But what I'm plotting here is the reading time for that critical sentence of the one that either was negated or not negated. Now, what we found was that when we had contextual support, the negated sentences were read just as fast as the not negated, so the positive sentences. On the other hand, when we had a paragraph that did not help resolve or did not help clarify the negated sentence, what we saw was a big penalty, a big increase in reading time for those sentences when preceded by sentences that paragraphs that did not support the negation, whereas the positive sentences were read just as fast. Now, in this, the way that I'm thinking of this factorially, I have two independent variables, the positive and negative, and the contextual support, not supported or supported. And so those are two factors, each with two levels. So we would call this a 2x2 factorial design. And that's not how we make twos. A 2x2. Okay, that kind of looks like 2x2. So it's a 2x2 factorial design. And the main thing that we look for with this is interaction. So interaction, the way that I've plotted it, each one of these marks, it would be the mean for that condition, that combination of context and negation. And interaction means that the lines would not be parallel to each other. Now that is really the important part here, because if I didn't have the 0 line, then I would have two measurements, positive and negative, and showing that they weren't different from each other. Well, statistically, that is a null effect. So from a statistical validity point, that is what I wanted to demonstrate, that that these two are equal to each other, but a person who disagreed with my theory could say, oh, you didn't have a big enough sample size, you screwed up your experiment somehow. Those null effects are uninterpretable. Now, putting in the other condition, where this condition here, where we have the context that doesn't support negation, I'm able to replicate the finding that you get when you have sentences read completely out of context, like with no story coming up before it. And in those situations, you do see a slowing effect of negation. And like I said previously, the previous theory explained that, because that additional slowdown going from here to here represents the mental processing time that it takes to understand the positive sentence, it is raining, and then add in a not in front of it, or negating that proposition. Now, what we took these results to mean is, since there was an interaction, we can show there is a negation effect when you don't have contextual support, but that contextual support goes away. So there's no difference here, there's a big difference here, and so that illustrates the interaction. That illustrates what we were arguing in our paper, was that negation slows people down only in situations where that statement does not have contextual support. Now again, this is a factorial study because we have two factors, negation and contextual support. It's a 2x2 because each of them have two levels. And then in terms of plotting it out, what we want to do is plot each of the cell means, each one at the positive and supported, positive and not supported, negated sentence supported, negated sentence not supported. So there's 4 different types of stimuli that make up the 2x2. So 2x2 equals 4. What we wanted to illustrate here was how this factorial design lets me test multiple hypotheses. Now, I want to address also the main effect. So overall, you can see that negated sentences, on average, were read slower than positive sentences, because the average here is somewhere in between those two dots, pretty much right in between, and that is higher than this point here. So that would be, this line right here is the main effect of negation. Now, with contextual support, you can see that having context that supports it leads to faster times. So the fact that the line with the circles is above the line with the X's indicates that there's a main effect of context also. But in a factorial design, we want to start with the interaction. Are the lines parallel? And here the lines are not parallel, and so that indicates there is an interaction, and that was something that was predicted by my research group and not predicted by the dominant theory that we understand sentences by forming propositional representations or something like that. So I hope this helps illustrate how a 2x2 design can work. Hope it helps you understand what factorial designs are good for. In the lab, we have, what I would have done in class is we would have had you actually participate in the experiment, but it was a really simple experiment. We just had everybody answer on a scale from 1 being icky to 7 being yum yum, delicious. How delicious are the following foods? And we gave chips and French fries, so tortilla chips and French fries, and asked when combined with salsa, so chips and salsa, okay, that's delicious. French fries and salsa, how delicious is that? Chips and ketchup versus chips and French fries and ketchup. And then also we asked just unsalted French fries, unsalted tortilla chips versus salted tortilla chips and salted French fries, and just had people rate those. What I have in the lab are the means and the standard deviations of the ratings that we got when we did that last semester. And so what I'd like you to do is answer the questions, and you'll make a graph sort of like this one, where you plot out the results and address, first off, is there an interaction? And then if so, explain it, like there is a difference here, there is no difference there. Or if there isn't an interaction, like the lines are parallel or nearly parallel, you'd say, okay, which one's more delicious? Salsa or ketchup, French fries or tortillas? Um, and just work your way through the results of that experiment. If you have any questions, please message me on Canvas. I understand that we're going to be online for the rest of the course, so please reach out if I can help you through as we go through the rest of this semester. Let me also just, this is a tough time for a lot of us. Let me try and reassure you that in my many decades now, oh my gosh, of teaching, I think it is safe for me to say that I've never had a student fail a course who did all of the work. Now, I can't guarantee, obviously, that if you turn in every assignment that you will pass, but if you don't pass, you'll be like the first one ever. So it's really unlikely that if you just make sure that you don't have zeros in your grade book, probably there's going to be a good result. I can't guarantee an A, I can't necessarily guarantee a B, but for the most part, so far in 27 years of teaching, I don't think I've given a D or an F to somebody who didn't have missing assignments or missing test scores or things like that. So it seems hard. I know this is a difficult class. The writing is tough. And I'm trying to get feedback to everybody as soon as I can. We're all dealing with this. If I can give you some reassurance, if you just do the work, almost definitely things are going to work out well. So if you need help, like you're not sure how to get things done, you're not sure what's being asked, let me know right away. I'll do my best to answer the questions. But aside from that, just I will grant grace as much as I can, just understanding our situation. Thank you. I hope you're healthy. I hope that your families are well. And I really wish that we could be meeting in person. I don't love this, but this is what we have for now. I miss you guys and hope you're doing well. So I'll see you online. Thanks.